Math 2, Unit 4.3, Angle Bisectors. So yesterday we talked about perpendicular bisectors. Okay, and a perpendicular bisector was perpendicular to the side and it bisected the side that intersects. Hopefully, angle bisector is pretty straightforward. It is simply a line segment or a ray that bisects or cuts an angle in half. We've already talked about that in Unit 3. So if we look at this angle right here, the angle bisector cuts it into two equal smaller angles. Okay? So an angle bisector theorem, if a point is on a bisector of an angle, then the point is equidistant from the sides of the angle or the rays of an angle. Okay? And we draw that like this. Okay? The distance from any point on an angle bisector to the side of the angle is equal. All right? Now, we always choose the shortest distance, right? So when we talk about a point on the angle bisector, we're always talking to the shortest side back to the ray of the angle, which of course is going to be perpendicular to that, right? So if a point on a bisector of an angle, then let's see, angle bisector. If a point is on the bisector of an angle, then it is equidistant from each side of the angle. Okay? Angle bisector theorem. If a point is on the angle bisector, it is equidistant from both sides or rays of the angle. Okay? And the converse of the angle bisector theorem is if a point is on the interior of an angle and equidistant from the side of the angle, then it is on the angle bisector. Okay? So what they're saying is this point right here is the same distance from that side as it is from that side. Well, then that has to be the angle bisector. Okay, and it's important that you realize that it's always going to be a perpendicular distance. Okay, because if we're looking at, say, the distance from this pen to the paper, the shortest distance is always going to be the perpendicular distance. I don't know, oops, I can't even see. I don't know if that makes sense really, but the shortest distance to the side is going to be when the pen is perpendicular to that side. Make sense? I don't know. We'll see. All right, and on a triangle, if we draw the if we draw the angle bisectors from each vertice, meaning this is an angle bisector, and over here, this line segment is an angle bisector, and on the third one, that's another angle bisector. So if we draw all three angle bisectors of a triangle, there's going to be a point of concurrency. That point of concurrency is called the incenter. Okay? The incenter is the point of concurrency of the angle bisectors of the angles of a triangle. The incenter is equidistant from the sides of the triangle. And I can prove that pretty easily now that I got my compass here. So you remember we talked about this yesterday. A compass can only measure distance, right? So if I measure the distance from there, and if I don't change it, if this is a good picture, it's not a good picture because this is kind of messed up. Gonna have to redraw this. This is a little bit better. This is not. Gosh darn it. Well, our picture isn't great here, unfortunately, but what's supposed to happen is if I draw this circle should touch all three sides of the triangle. But you can kind of tell right here, this doesn't look like it's really accurate down here. But that's what it's supposed to do. And hopefully I think we show it later on down here somewhere. Somewhere we'll show it. Okay, so the end center is equidistant from all three sides. So if we draw this back, and of course it's perpendicular, all three of those lengths will be congruent. Okay? Any questions on that? All right, let's go through some examples here. So find PQ. Well, you notice right here, this says this is an angle bisector, right? So since SQ is an angle bisector, what we said earlier is any point on the angle bisector is equidistant from the sides of the angle. And you notice we have perpendicular there. So we just simply say 8x minus 27 equals 4x plus 33. Subtract 4x from both sides, we get 4x. Add 27 to both sides, we get 60. Divide both sides by 4, we get x equals 15. But we are looking for PQ, which means 8 times 15 minus 27. That's 120 minus 27, which is 93. So the length of PQ is 93. Any questions on that? Okay. All right, let's take a look at number, I guess it's not really a number, but this is actually the converse of the angle bisector theorem. It says if a point is equidistant from the two sides, then it is the angle bisector. Well, if you look, B is equidistant from C as it is from A. And A and C are both on this angle ADC, aren't they? So that means that DB is an angle bisector of angle ADC, which means these two angles are congruent, which means 12x minus 19 equals 9x plus 5. Does everybody understand how I got to that point? Okay. So we'll subtract 9x from both sides and we get 3x. We'll add 19 to both sides and we get 24. Divide both sides by 3, we get x equals 8. But we're looking for angle BDC. BDC is right here, which is 12 times 8 minus 19, which is 96 minus 19, which is 77. So the measure of angle BDC equals 77 degrees. How are we doing on this?
Pretty simple.
Pretty simple. All right, let's flip it over. Let's do these 6 problems right now while I come around. And I think I need to stamp a few more pages, right?
Yeah.
So while you are working on these 6, I'm going to come around and stamp the rest of your packet.